It's like whether the polynomial increases from as you go on further to the right or decreases, that kind of thing. Okay. So, but like I said, graphing quadratics is what we're going to focus on today. All right. And so we'll start with looking at, I guess, the kind of standard form that we run into. Okay. And the name standard form, not so important. All right. I'm not going to be like, what is the standard form of a quadratic or anything like that. But okay, and A is not equal to 0. So A, B, and C are just going to be numbers, right? A is not equal to 0, bless you. And so that's, you know, bless you again. And so we have something like this. AX squared plus BX plus C. Right. Okay. Why is it important here that we say that A is not equal to 0? Why is that stipulation important if we're talking about quadratics? Right, yeah, we wouldn't have the x squared term that makes this thing quadratic in the first place. It would just be linear, right? Bx plus c is just a linear equation. So we need A to not be 0. We need A to not be 0 there. That's right. Okay? So for the graphing of a quadratic equation from this form, or given this format, okay, we have a couple options. But one of the key kind of points we want to locate is the vertex, right? And so the vertex, if you remember here, I'll draw like a little sketch, okay, of this. Okay. If we graph just sketch a graph of a parabola here. The vertex, right, is the lowest point or the highest point, yeah, depending on the orientation of your parabola. Okay. Another way we talk about the vertex is it could be, so if the vertex is the lowest point, another name that we have for that is a minimum, yeah. So we can talk about it being a relative minimum, okay, like that. Or really, in this case, we could really talk about it being an absolute minimum too. These are words that you're going to see later on in calculus as well, and more specifics about like, you're going to be identifying those and calculating them from other things, okay? But I think in this case, we'll just stick to the relative minimum. But it's also an absolute minimum, as in it is the absolute lowest point of the graph, right? Whereas the vertex here, right, we could call it a relative what? Maximum. Yeah, for the other one here, that's right. Okay? Or, again, we could call it an absolute maximum as well because it is the highest point on our graph, okay? And we'll talk more about what the relative means a little bit later when we talk about polynomials, graphing those. Okay, it'll make a little bit more sense. Okay, so just understand that's another like other words we could use there too. Okay, so I know maybe if you had like algebra 2, right, or if you did have algebra 2, right. So in algebra 2, right, you focus on things like the axis of symmetry and stuff like that too. I'm not too worried about those because like it's really not that important. But the vertex is an important point. We want to be able to find that. So given standard form, how can we find the vertex? Well, one option is we can find the x-coordinate, okay, of the vertex by using x equals negative b over 2a. Okay, bless you. And that b and that a, those are the coefficients from that function, our quadratic function there, okay? So the x-coordinate will always be equal to negative b over 2a, okay? You might recognize that. Where is that from? What's that? Completing the square. Okay, so we might use it in completing the square. That's true. It's also in the quadratic formula, right? It's the first part of the quadratic formula. Negative b over 2a, and then you have plus or minus, and you have the square root of b squared minus 4ac over 2a as well, okay? So it's the front part of that quadratic formula, okay? Which kind of makes sense because the zeros are located, you know, kind of equidistant from that vertex, right? In the x, you know, on the x-axis, right? So like, you're going to go to the right some from the 0, and then to the left the exact same amount. So that's the plus part. You go to the right of the x-axis, well, for you guys this way, or the right of the x-coordinate there, and then for the minus part, you go to the left, right? So that creates that, you know, kind of, that creates that middle point for us right there. Okay. This is also, therefore, the axis of symmetry. If you remember that too, the equation of the axis of symmetry, x equals, and then whatever that number ends up being. Okay? So, let's have you guys then just find the coordinates, okay, of the vertex of, and then I'll just give you, so this is one, I'm just going to have you guys try this one. I think you should be okay without me kind of going through it, right? So 2x squared minus 8x plus 6. Okay. So go ahead. Find the coordinates. So I'd like an x and a y coordinate. Once you found the x, also find the y for me too, please. Okay? I do like 30 more seconds here. 30 more seconds.
Negative b over
2a.
2. Where do you find the y coordinate again?
Good question. What do you think you should do? You have a relationship given to you here, don't you?
Yeah,
That relates
back
x
in.
and the y's.
So that's
Okay.
2 times 2 squared. 1 squared. 16 plus 8.
All right, Rohan, what'd you come up with for the vertex here?
I get 2, -2.
2, -2. Okay, so I'm assuming you got the 2. How did you get how did you get the x coordinate there? What did you do?
Minus b over 2.
You used negative b over 2a. Okay, and that's fine. There's other ways to do it. That's one way to do it. Okay, and then what about the y coordinate? How to find that?
Basically just plug in negative b over 2a into the equation and got -2.
Yeah, so you can see here, right, we got our equation. Negative b over 2a would be negative negative 8, which is positive 8, over 2 times 2, which is 4. So 8 divided by 4 is 2. Okay. Once you get that x coordinate, you have a relationship here, right? So plug the 2 in for the x's here and here. Solve for y, you get the matching y coordinate of -2. Okay. And so then 2, comma, -2 would be your solution. In this particular case, this vertex we could also identify as a relative what?
Maximum.
Maximum? Minimum? Min? Okay. Well, the shape, again, is this going to be like...
That's right.
Yeah, so it's a relative, you agree now, it's a
Relative
relative
minimum.
minimum. Right. This is going to be a
Yeah,
U.
I forget. I always get it confused. I forget if the tip of the quadratic or the mouth of the quadratic ends up being positive.
Yeah.
If it's positive.
Gotcha. Yeah, I see what you're saying. Yeah, it opens upward, I guess, for the positive A. And then opens downward.
As
for the
opposed to
negative
pointing upwards.
Yeah, exactly.
It points downwards.
Yeah, I would say opens upwards, opens downwards kind of thing. That might help you. U or the bell. Okay, good. So yeah, this is relative minimum. All right. So let's go ahead and graph this thing because I think we kind of have enough information, right? That vertex is one of the most important points we can get, for that graph. So let's actually sketch the graph here. Y equals 2x squared minus 8x plus 6. Okay, and so again, we know we need to have the point 2, -2 at least. So let's see here. Okay, and so let's see. I'm just going to count by ones, I think. Hopefully that'll be okay. So 2, -2, there's our vertex right there. Okay. And so when it comes to graphing here, I mean, obviously we want to find the vertex. Okay, and graph it. Okay, because again, the vertex is probably the most important thing. And we'll be able to, use different methods here, right? If this were in a different form, right, like vertex form, then we would just pull the information out and graph it.
And you could just plug in 1 and 0 and mirror it.
Exactly. So let's, exactly right. So what we're going to do then is just pick some extra x values here. Kind of like how you, maybe first learned how to graph things. You just made like a table of values. I suggest you pick stuff near the vertex, okay, to graph. Okay, and then like Jeff said, we're also going to be then using symmetry because we know that parabolas are symmetric about, well, their axis of symmetry, which is the vertical line that goes through the vertex there. Okay, nothing too crazy here, right? Stuff that we have seen before. So Jeff suggested 1 and 0, so let's go ahead and do that here. I'll make a little chart. Okay, so we'll plug in 1. We plug in 1 there. What do we get for our y value? A 0. Okay, so 1, 0. That means what else is a 0 here? 3, right? Yeah, if 1 is 1 away from the axis of symmetry, then 3 is 1 away as well. Okay. And then 0, I think you suggested, right?
6.
Yep, 0 gives us 6. So 0, 1, 2, 3, 4, 5, all the way up here at 6. Okay. And so if we have a point at 0, 6, we'll also have a point at what?
So that's 1, 2, 3, 4.
Yeah, 4, 6.
4, 6.
Okay. And then, yep, we can just connect the dots here. Like that. Okay, and of course arrows to show that it keeps going. Okay, very simple, very straightforward stuff, right? You can see now, though, we see that relative minimum, kind of behavior of the vertex there, right? It is the lowest point. So again, we could also call it the absolute minimum too, if we wanted to. All right, easy peasy. Questions on any of that? We're all good. Okay. So I'm going to see if I can kind of bled through. I don't know. I might use another sheet here, I guess. Okay. Would anyone like another sheet of graph paper here? Or are you guys just going to run it back? Anyone want another sheet? You got it, right? Anyone else another sheet? Okay. If you need some, just let me know. I'll get you some more here too. But I'm going to go ahead and move on to that because my pen's kind of bled through. All right, so that's, we see the standard form there. We got some other forms though too. So for example, we have vertex form.
I always forget what vertex form is, but I can recognize it when I see it.
So it looks like this. Bless you. It looks like this. Y equals a parentheses x minus h quantity squared plus k, right? It's kind of like when we look at transformations of y equals x squared, right? That parent function there. That's how we look at the transformations and things. Okay. And so in a case like this, right, the vertex, that very important point, okay, is at what coordinates? HK. Yeah. Remember, it has to be minus H, and then it's at H, and then plus K there. It makes K. Okay. So X minus H, and then plus K. Okay, exactly right. We'll take this one here. Alrighty. Again, not worried too much about the axis of symmetry there, so we're not going to focus on that too much. So yeah, let's take a look. Let's get an example here. Okay, let's do an example of this. So let's graph y equals negative 1/4 x plus 2 squared plus 5. Okay. And so Jenna U, where is our vertex going to be? What are the coordinates for our vertex?
2 and 5.
Okay. Positive 2 or negative 2?
Negative 2.
Negative 2, and then positive 5 or negative 5? Positive 5, yes. Very good. Yep. Negative 2, 5 for the vertex there. Okay. So let's see here. I'm going to try and again sketch this. So, oh, also, right, is this vertex going to be a maximum or is it going to be a minimum in this case? Jenna, you want to answer that one again? What do you say?
Maximum.
Minimum, maximum? Yeah, it's a maximum. Exactly right. Maximum, okay? Because it's going to be the bell shape, right? And so that vertex is going to be the high point there, that negative. Okay? Yep. So we know it's going to be a maximum here. All right, anywho, let's actually graph this here. Make sure I get enough space. All right, so negative 2, 5, 1, 2, 1, 2, 1, 2, 3, 4, 5. And again, I'm just going to count by ones. You can choose to count by other things if you want to. I'm going to count by ones. Okay. So there's negative 2, 5. And again, we'll get some more points. All right, let's pick some more points here. So, suggestions for some x values to plug in here? Negative 1? All right, let's do it. Let's do it. Negative 1, we'll plug it in. Okay. Negative 1 plus 2 is 1. Squared is 1. Times negative 1/4, fractions, negative 1/4. Okay. Negative 1/4 plus 5. Okay, negative 1/4 plus 5, 19/4. Okay, or you could say 4.75. Okay, that might make it a little bit easier to like estimate where that's going to be. All right. So yeah, so negative 1, and then 1, 2, 3, 4.75. So there's halfway, there's 3/4, like right there. And then we'll just mirror that over to here as well. All right. Let's try 0. 0 is going to be nicer to us. So 0 plus 2 will be 2, squared is 4, times negative 1/4 is negative 1, plus 5 is 4. So 0, 4. Okay, 0, 4. That's nice. 1, 2, 3, 4, point there. And then 1, 2, 3, 4, point there. Okay? You can get as many as you want. I'll do one more here. I'm going to do 2. Okay? So 2 plus 2 is 4. Squared is 16. Negative 1/4 of 16 is negative 4. Plus 5 is positive 1. So 2, 1 is what we get. So 1, 2, 1. And let's see, that's 1, 2, 3, 4 away. So 1, 2, 3, 4 away this way also. There. Okay. There we are. Something like that. I would suggest, for some of these that you do, beyond the vertex, I suggest that you do at least 2 more points, and then with their reflection. So a total of 5 points. Okay, total of 5 really, but it's just the vertex plus 2 more, and then you reflect those 2 more, just to get an idea about, again, the shape of the graph. Excuse me, and stuff like that. Okay, so again, there's that idea. All right. Now, believe it or not, right? You can take something that's in standard form, for example, and you can rewrite that in vertex form. Okay, and that would be from completing the square. So, for example, if you didn't want to use the negative b over 2a, if you always wanted to use vertex form, you could just complete the square for this quadratic here, okay, and that would put it in vertex form, and you can identify the vertex that way, okay? Just kind of your choice there, but that'll be that. All right, last form that we kind of sometimes see quadratics show up in is intercept form. Last form we see that show up in is intercept form, and that is y equals a times x minus p and then like x minus q. So it's essentially like the factored version. It's like the factored version of standard form. Okay, and again, the names for these don't matter too much. It's more just being able to recognize like what you're given, the information. It's supposed to be a q. There we go. Now it's more Q-like. Okay, so in this case, right, this is like the factored version, so we have the x-intercepts, okay, or the zeros, we'll say, which are P0 and Q0. Given those x-intercepts then, how could we use those to help us find the x-coordinate for the vertex at least? How can we use the p and the q there to help us find the x-coordinate for the vertex? Yeah, Danny? Find the midpoint. Okay, so what would that look like then? What would we do with the p and the q? To find the midpoint of those two, what would we do with them? You got it, exactly right. Atom, divide by 2. So the vertex x-coordinate because again of symmetry there, right? The vertex x-coordinate will just be x equals p plus q. Ooh, that was not a good looking q there. P plus q over 2. Okay. Now, do I expect you to memorize all these things? Not really, no. You don't really need to memorize it, right? If you can just, if you know that, you know, these will give us our zeros, which are really the x-intercepts, then just find the midpoint of those two. That'll give you the x-coordinate for the vertex. And of course, once we have the x-coordinate for the vertex, how can we find the y-coordinate? By doing what? Yeah, plug it in. Plug it in. Okay, plug it back into the function, get the matching y value. That's right. Okay, so let's just do a quick example of that one, and then I'll have you guys try two on your own here. Let's say y equals x plus 3 times x minus 1. So what are our x-intercepts going to be here? What do you say, Matty G? What are our x-intercepts going to be here?
They're going to be -3 and 1.
Yeah, -3, positive 1. You got it. Okay. Very good. So we got 2 points right away, right? And now we can find the vertex. Okay. Using what Daniel said there. So we'll take the one and the other, add them up, and then divide by 2. So -3 plus 1 is -2. Divide by 2 is -1. Okay, and then we'll plug that back in like you guys said there. Okay, and if you want to get fancy here, I don't know, because like if you want to show that we're plugging in -1, right, because this is not a function, it's like y. It's like when you have a function, right, it's easy to show that you're evaluating something at a certain point. You just say f of whatever or g of whatever. But when you have y, there's no like y of something, it's just y. But to show that you're evaluating y at a particular x value, you can put like a vertical bar there, and you can write x equals -1. So this means y evaluated at x equals -1. Okay, and that's actually, you know, kind of more appropriate ways to write that than just like kind of subbing it in. Because y is equal to this. Y is not equal to this. Okay, y evaluated at x equals -1 is equal to that, right? And it is a y coordinate. So anyway, that'll be more important when it comes to calculus and stuff like that. Okay. So vertex is at -1, -4. Okay, and I'll just do a quick sketch of that then.
So, to clarify, that means y evaluated at x equals -1?
Correct. Like you're substituting in.
So it's like a. So that would, after the x equals -1, you put a second equal sign, and then have what it would be.
Yeah, but if you look here, it's kind of like it's like a sub. It's not on the line here. It's like below the line kind of thing. Okay, it's like a sub, like kind of subscript. I guess you would say that.
Oh, I didn't realize it was a subscript.
Yeah, it's a subscript. Yep.
Okay, so I'll make my x small.
Yep, make your x small and like kind of like down on the line there too.
X equals -1.
Okay. Did I see another hand? No. Okay. All right, and so again, we'll just plot the 2 0. So -3 0, 1 2 3, and 1 0 1 like that. -1 -4 -1 1 2 3 4 right there. Okay. And let's see. Do I need a couple more points? Yeah, I'll go ahead and say. Let's try plugging in like 0, for example, here. So 0 plus 3 is 3. 0 minus 1 is -1. So -3 0 -3 1 2 3, and then mirror that over there. And then we've got our quadratic there. Now, in a case like this, we can also identify, again, our vertex as a relative minimum or relative maximum before we graph it. Again, just looking at the coefficient here in front, right? It's positive, right? It's a +1 right here. So this is going to be a U-shaped parabola, which would make this a relative minimum, right? Or also an absolute minimum again as well. Okay. Questions on any of that? Ready to do 2 on your own here? Okay, here we go. Basic stuff, right? Basic. I'm just going to squeeze it in over here on this side of the graph paper. All right, so for you guys to try, I want you to graph y equals x squared plus 2x plus 1. Okay, and then also graph y equals -x plus 3 squared plus 5. Okay. So there you go. Give those 2 a shot. crash through the window. You're the first one to go, Simeon. Sorry. Protect us.
It's a
Simeon.
ghost mowing the grass.
Yeah. Save us.
Your shadow.
Question, Jeff? Yes. Didn't break anything, did it, Jenna? All right, let's take a look at what we've got here. All right, so there's the first one.
Yeah, you got it right.
All right, good. So I chose to factor this thing. It was already a perfect square, and so I could use that vertex form. Okay, my h is going to be -1, my k is 0, -1, 0. I'm going to assume most of you probably did the negative b over 2a from that form, but you could do it this way, or you could also use the zeros as well. Okay, in this case, the vertex and the zeros are the same point, right? The vertex is the 0, okay, in this case, right? Also, it's a relative minimum, right? A minimum, because it's the bottom point of the graph there, right? And absolute minimum really is the lowest point, and I got some more points there too to graph it. Okay. And then the last one there was already in vertex form, so just went ahead and read the information from it. -3, 5 is vertex, got some more points. This in this case is a relative maximum or absolute maximum as well. Again, that's because that negative sign in front there. Okay. So, and again, I feel like it makes more sense to call this thing an absolute maximum because it is the highest point, but technically it would also classify as a relative maximum as well. We'll talk more about what I mean by the relative part when we get into polynomials and stuff like that. Okay? Now, there's one more thing. I was supposed to teach you guys yesterday at the end of the quiz, but we just didn't quite have time to do it. So I want to show you that real quick, and it's the and then we'll get you guys started on your assignment here. Okay? It shouldn't take too long, but it's the bonus from that last quiz we took, not the one that we just had, but the one prior to it. So Laura, this is going to kind of spoil it for you. I don't know. Do you want to step out and then learn it, or do you want to just sit and learn it and then you just won't get the bonus opportunity? Sit and learn. Okay. Do you have a question though?
Yeah. So for the test, will we have to graph like 5 points, or can we just graph 3?
I'll be okay with just 3, I guess. Yeah, I'll be okay with just 3 as long as you can give me the idea of the, of the graph. Yes, thank you. Words. Okay. So real quick, I just want to show you that roots to the equation, how to do that, okay, because we are going to be using that. Okay, you'll need to know it for the test and stuff like that upcoming here, so it's going to be more than just a bonus thing, okay? And I'll just do like, well, 3 examples, I guess, here, and then we'll just get you guys started on the assignment, okay? And I'll give you one if you wanted to try it too, but anyway. So if you remember the directions from the quiz, it was to write a polynomial that has the given roots. Okay, we're pretty good at taking a polynomial and getting its roots, but going in the other direction, starting with roots and creating a polynomial, we haven't really done that. Okay, again, it was an opportunity for bonus, but that's it. So as an example here, let's take a look for, with a polynomial that has the roots of negative 8 and 2. He's back to threaten us again. Okay. So, if we have roots of negative 8 and 2, what are factors that would yield these roots? So, for example, if negative 8 is a root or a 0, right, what would be a factor that would give us that as an answer? Now, x plus 8, exactly right. Okay? And then if 2 is a root, what would be a factor that gives us 2? X minus 2, exactly right. Now, are these the only 2 options we have that would yield negative 8 as a root and 2 as a root? Okay. Are those the only 2 options? Ethan says no. What do you got? What does everyone else think then? Are these the only 2 ways that we get negative 8 as a root and 2 as a root? What's another option? For example, what's another option I could have here as a factor if I still want to get negative 8 as a root? Adrian?
X squared plus 64.
Okay, x squared plus 64. That would then include both negative 8 and positive 8, which is still okay because, I mean, it doesn't say I couldn't include other roots there.
X squared minus 64.
Oh, yeah, sorry, there you go. X squared minus 64. Yes. That would work. Rose, you have another idea?
I don't think it's correct.
Okay, so you want to hold off on saying it then? What were you going to say, just out of curiosity? Negative 2 cubed. Okay, so if we had like, we could do that maybe. If we had like an x cubed, right? So if we made that x cubed or something like that, and then like the minus an 8, that might work for the negative 2 there. Yeah, that could work. I'm also thinking, so we don't have to go that hard. We don't have to go that hard though on the options. We could just make it like 2x plus 16. 2x plus 16. That would work, right? Because 2x plus 16 would still solve to give you negative 8, right? This could be, 6x minus 12. 6x minus 12 here, that would still, when you solve it, give you 2. So there's really an infinite number of possibilities here. We picked the 2 most simple ones, which is fine. Okay. So technically that's our polynomial. We could also, of course, FOIL this out. So we get x squared plus 8 minus 2, so plus 6x, and then minus 16. And that would give us, the polynomial there. Okay. What about if we had roots like 4 and negative 1/3? What would be our factors here? What factor would give us 4 as a solution? X minus 4, yeah. What about negative 1/3 though? Okay, so 3x plus 1. Could I put, is that okay? Is x plus 1/3 okay? Would it work? It would. You have to multiply with fractions and stuff like that, so whether you want to do that or not is your choice. Probably the most straightforward one is this one on top though. Okay, so it would be what? 3x squared minus 12 but plus 1, so minus 11x and then minus 4. Okay. But again, you don't have to use that 3x plus 1, you have x plus 1/3. It's another option. All right, but of course, these weren't the hard part of that bonus question. The hard part of the bonus question was this. I had roots of like, it wasn't this exactly, I don't think, but it was something similar to this, right? 4 plus or minus root 3. How the heck are we supposed to do this one? Oh, Jen, a question?
Where'd the 11 come from?
So,
Just do this one?
FOIL it, so x times
right,
3x.
I see it now. Okay.
Yep. Yep, that's okay. Okay. So this one's a little bit trickier to see, right? Our 2 roots being x plus or minus, 4 plus or minus root 3. So let's break it So remember, for a root, that's an x value, right? Or it's a 0 or a root, it's an x value. So I'm going to say x is that 4 plus or minus root 3, and we're going to kind of work backwards and undo this. And so I don't like that plus or minus, so I'll make 1 be 4 plus root 3, and 1 be 4 minus the root 3 there. And so one thing we could do here is like literally just get this equal to 0, so minus 4 minus root 3, and oops, x minus 4 plus root 3. And then these could be our two factors. We can just multiply those together. Okay? So again, get them equal to 0, right? And so these become now the factors that we can then multiply together. And that will multiply back together to give us, you know, a polynomial here. Okay? It's going to be kind of tricky. I mean, we can multiply it out. FOIL kind of fails us here because FOIL only works for binomials. These are trinomials, but it still can work. Just remember, everything in here multiplies with everything in here, right? So this x right here multiplies to the x, the minus 4, and the plus root 3. So we'll have x squared minus 4x plus x root 3. And then the minus 4 multiplies to everything too. So it'll be another minus 4x. Minus 4 times minus 4 is plus 16. Minus 4 times root 3 is minus 4 root 3. And the negative root 3 multiplies to everything. So it's minus x root 3 plus 4 root 3. And then negative root 3 times positive root 3 is negative 3. Okay, this is one way to do it. I'll show you another way to do it too, but this is one way to do it. All right, you just multiply it all out. Okay, and then actually some things cancel here, I think. Right, so what cancels out? Yeah, the 4 root 3's cancel. The x root 3's cancel. Okay, and we can just combine everything else then. So it becomes x squared minus 8x plus 16 minus 3, so plus 13. And so there's a polynomial that would give you 4 plus or minus root 3 as zeros there. Okay. That's one way to do it. Let me show you an alternative way that's probably a little bit easier. We'll go back to starting with the x equals 4 plus or minus root 3. I'll subtract the 4 over. So I'm not going to split this into two things. We'll just subtract the 4 over. Okay. And then how can I eliminate that square root on the right-hand side there? Square both sides. Okay. Positive root 3 squared and negative root 3 squared will both be what?
9.
Not 9. 3, because you're squaring the square root there, Jeff. Yeah. And then squaring x minus 4, well, that's where we have to multiply it out. So it'll be x squared, let's see, minus 8x plus 16. Subtract the 3 from both sides. And voila, you get the same exact answer as we did right down here, without all that multiplying two trinomials together mess. Okay, so your choice there. Your choice.
Do you have to FOIL it out for like the
You should be able to, again, if it's a multiple choice and you have to like match it up and stuff like that. Okay, you should be able to, yes. Okay, so that's that. Okay, if you want one to practice, I'll give you one here. Or if you want to go straight to the homework, I'll also say you can do that. So here, if you want one to try, I'll give you this one, and then I'll show the answer in a couple minutes here. Okay, or like I said, if you want to go right to the homework, you're feeling good about this, I'm going to post that homework right now to Google Classroom, okay? It's a worksheet.
Yay, worksheet.
Okay, but and I'll get you some more graph paper too, because it's going to involve graphing. If you just want to sketch the graphs, that's cool, I get it.